I'm Chogada. Today we will discuss example based on maximum height. Okay. So now you can see, so when projectile is following the parabola path, what should be the maximum height? Okay. So at the highest point, it means at this position, horizontal component of velocity, so that is u cos theta. But vertical component is 0. So vertical component is 0. So by using this, we can find out the maximum height. How? So final velocity is 0. So our equation is v square is equal to u square minus 2gh. Okay, so v square is equal to u square plus 2as. Here u, the vertical component of velocity, so that is u sine theta. Acceleration is g, s, that is maximum height h, and instead of plus, for motion is in upward direction, value of g is in downward direction. Okay, so it's a minus. So you can see final velocity is 0, u sine theta square minus 2gh. So h is equal to u square sine square theta upon 2g. Okay, so by using this equation, we can find out height h or maximum height h. So that depends on vertical component of velocity. So we can write the same formula in terms of vertical component. Okay, so instead of u sine theta, we can write v or uy. Okay, so h is equal to uy square upon 2. Okay, so when the height is maximum, so for that sine square theta should be maximum. For that sine theta should be maximum. So sine theta maximum, that is 1, and that is equal to 90. Okay, so when sine square theta maximum, that is equal to 1, theta is equal to 90, and h maximum, that is u square by 2g. So remember this formula, u square by 2g, so that is maximum height. Similarly, for complementary angle theta and 90 minus theta, so if we take the ratio, the ratio of h1 by h2, so h1 is u1 sine square theta, and second u2 square sine 90 minus theta square. Okay, so u square sine theta upon 2g, u square sine square 90 minus sine 90 minus theta cos theta, sine square upon cos square, u cancel, 2g cancel. So finally tan square theta. So if angle theta is given, we can find the ratio of height h1 by h2. So remember this formula, so it will be useful while solving the example. So h1 by h2 is equal to tan square theta. Let us start with the example. A cricketer can throw a ball to maximum horizontal distance of 100 meter. So that is r is equal to 100. With the same effort, he throws the ball vertically upward. So vertically upward, it means theta is equal to 90. The maximum height attained by the ball, already we have discussed h maximum when theta is 90 degrees, so that is u square upon 2g. So now u is given, not given, so range is given. So from the range we can calculate h maximum. So r maximum, that is equal to u square by g, and that is equal to 100. So directly here we can replace u square by g, so that is 100. So 100 by 2, it means 50. The answer is 50. So horizontally he can throw up to 100 meter, but vertically he can throw up to 50 meter. Okay. So for maximum raise, if you want to find height, in that case we have to use the equation r is equal to 4h cot theta. So here we cannot use 90. Okay. So this equation, when range is maximum, you can find the height. But here it is 50 meter. A ball thrown by one player reaches the other in 2 seconds. Okay, it means what is given? So that is time of flight, that is equal to 2 seconds. The maximum height attained by the ball above the point of projection will be. So above the point of projection, it means this height. So h is equal to u square sine square theta upon 2g. Now u is given, not given. Sine theta is given, not given. But time of flight is given. So time of flight. So time of flight is equal to, so time of flight t is equal to twice u sine theta upon g, and that is equal to 2 seconds. So 2 cancel. It means u sine theta, that is equal to g. So now use here. So u square sine square theta. So you can say g square upon 2g. So g by 2. It means 5. Okay. So height is 5 feet. Clear? So you can see here, you can solve examples very easy. So all are equation based example. Two stones are projected with the same magnitude of velocity but making different angle with horizontal. Okay, so first stone, and you can consider second stone with same velocity. So u is same. The angle of projection of one is pi by 3. So consider angle of projection for first pi by 3, and its maximum height. So that is, we can say, suppose maximum height pi. The maximum height attained by the other stone with as pi by 6 angle of projection. So in the second case, if angle of projection, so that is pi by 6. Okay, so what should be the height pi? So now you can see pi by 3, it means 60. Pi by 6, it means 30. So 30 plus 60, so that is 90. Now we can say it's a complementary angle. So for complementary angle, h1 by h2 is equal to tan square theta. So theta we have to consider for the first stone. So for the first stone, angle is pi by 3. So replace tan square pi by 3. Pi by 3 means 60. Pi by 3 means 60. Root 3, it means 3. So h1, so initial height, so that is y, and h2 that we want to find out, it means h2 is equal to y by 3. So h2 is equal to y by 3. So if angle of projection is 60, height is equal to y. Angle of projection 30, then height is equal to y by 3. Okay. So from option also we can select without calculation. For 60 and 30, for naturally 30, height should be less. So we can say y by. The Pankaj and Sudhir are playing with two different balls of mass m1 and m. Was for Pankaj, and second one is Sudhir. If Pankaj throws his ball vertically up, it means in this direction, vertically up, it means theta is equal to 90. And Sudhir at an angle theta. Okay, so Sudhir will throw the ball at an angle theta, means with vertical theta. Both of them stay in our view for same period. It means time of flight for Sudhir and time of flight for the Pankaj, both are same. The height attained by two balls are in the ratio. So for suppose h1 and h2. So take the ratio h1 by h2. Here these angle are complementary angle. Angles are complementary angle. Then we can consider. But theta is given, not given. Okay. So now first calculate h1. So h1 for vertical, h1 is equal to, suppose initial velocity u1, then u1 square upon 2g. For 2, so that you can say u2 square sine square theta. So theta, it should be with vertical or with horizontal. With horizontal. So with horizontal, this angle is 90 minus theta. So sine square 90 minus theta. So I can write u square by 2g upon, here also I have to write u1 square by, similarly u2 square sine 90 minus theta cos square theta upon 2g. So 2g cancel. So u1 square upon u2 square cos square theta. Answer is not given. So now use the condition time of flight for Pankaj and time of flight for the Sudhir. Both are same. So time of flight twice u1 sine. So for first case 90 upon g. Twice u sine theta upon g. So twice u2 sine angle is 90 minus theta upon g. So now you can say u1 sine 91. So u1 is equal to u2 cos theta. So u1 is equal to u2 cos theta. Replace u1, u2 cos theta, both are same. It means ratio is 1. So in both the case, ratio is same. Sine, okay. So here, if you throw it vertically or if you throw it at an angle theta, but if time of flight is same, then this ratio is 1:2. Okay. So follow the step. Okay. So first write down the equation. Then if you are not getting the answer, then check which parameter we have not used. A boy aims a gun at the bird from a point at horizontal distance of 100 meters. So consider boy and consider bird. Okay, aims the gun which is at a distance of 100 meters. So if the gun can impart a velocity 500 meter per second, so u is equal to 500 meter per second to the bullet, at what height above the bird must he aim his gun in order to hit it? Okay, so if he target the bird in a straight way, okay, the gun will actually follow parabola. Okay, gun will actually follow parabola, and this distance, so that distance is called 1/2 gt square. This distance is 1/2 gt square. So if he target the bird, okay, but actually the bullet will not hit the bird. So actually he has to target, okay, above the bird, and this height should be, that is 1/2 gt square. In this case, okay, so if he will target the bird in this way, the bullet will follow this path, okay, and it will hit the. So to find out this distance, we have to calculate 1/2 gt square. 1/2 g. Time is given, time is not given, but distance is given and velocity is given. So time is equal to distance upon velocity. So distance 100 meter, velocity 500 meter. So time is 1/5. So here we can write 1/5 whole square. Write down g is equal to 10. So now 5, 1/5. Okay, so this is equal to 1/5 meter. Okay, so you can say 20 centimeter. Answer is 20 centimeter. So boy has to target a gun or bullet, okay, above the bird, and distance should be 20 centimeter. A maximum horizontal range of projectile. Maximum horizontal range of projectile is 400 meter. Now maximum height attained by it. Find out h. So here we can use our ready-made formula. Range r is equal to 4h cot theta. So for maximum range, theta should be 45. So if theta is 45, range 400, 4 into h cos 45, cot 45, that is 1. So h is equal to 100 meter. H is equal to 100 meter. And already we know r is equal to 4h. So r is equal to 4. Clear? The examples are comparatively simple. So next is energy of the projectile. So you can see, so while moving through the space. Okay, think about the energy associated with the projectile. So it possesses kinetic energy, potential energy. Okay, so potential energy at the starting point. So at the starting point, height is equal to 0. So potential energy is equal to 0. Kinetic energy. So if initial velocity is u, the initial kinetic energy is 1 half m u square, and that is equal to kinetic energy. So initial kinetic energy K is equal to 1 half mv square, and total energy, potential energy plus kinetic energy, so that is 1 half mu square. Okay, so at the maximum height, okay, so with increase in height, potential energy increases, kinetic energy decreases. So at the highest point, kinetic energy, so here velocity is 0, it means vertical component 0, but horizontal component is not 0. So kinetic energy is equal to 1 half mu square. Instead of u, write down u cos theta. So kinetic energy is equal to 1 half m u cos theta whole square. So that is 1 half m u square cos square theta. So 1 half m u square. So that is initial kinetic energy K. So we can write K cos square theta. It means kinetic energy at the highest point K dash is equal to K cos square theta. So remember this formula, at the highest point K dash is equal to K times cos square theta. Okay. Next, potential energy. Potential energy is equal to mgh. H. So h at the highest point, h is equal to, so u square sine square theta upon 2g. So u square sine square theta upon 2g. So g cancel. Okay. So 1 half mu square sine square theta. So 1 half mu square is k. So you can say k times sine square theta. So we can write the formula, potential energy is equal to k times sine square theta. So potential energy is cos square theta, and kinetic energy, sorry, potential energy is k sine square theta, and kinetic energy is k cos square theta. So remember this formula. Okay, at the highest point, kinetic energy cos square theta, potential energy sine square theta, and total energy, so that is kinetic energy plus potential energy. So you can write 1 half mu square cos square theta, 1 half mu square sine square theta, cos square plus sine square 1, so 1 half mu square. So total energy, so that is 1 half mu square, which is same as initial kinetic energy. So let us solve some examples. A projectile is projected with kinetic energy K. So initial kinetic energy of the projectile is K. Its range is R. It will have minimum kinetic energy. It will have minimum kinetic energy after covering a horizontal distance equal to. So at which point kinetic energy is minimum? It means at the highest point kinetic energy is minimum. So at the highest point, it means what is the horizontal distance? The horizontal distance is r by 2. So that is 0.5 r. Clear? So at the highest point, here kinetic energy is not zero anywhere. Okay, so minimum value of kinetic energy is at the highest point. A projectile is fired at 30° with momentum p. So p is the momentum, angle is 30°. Neglecting friction, the change in kinetic energy when it returns to the ground. So after completing the motion, okay, when it returns to the ground, okay, so what is the change in kinetic energy? So when it returns to the ground, its initial velocity is suppose u, final velocity is u, initial momentum is v, final momentum is also p. So change in kinetic energy, so change in kinetic energy 0. There is no change in kinetic energy. Okay, so that is law of conservation of energy. Okay, just direction of velocity changes, value remains same. A projectile is projected making an angle 45° with horizontal, having kinetic energy K. The kinetic energy at the highest point will be, so making angle 45. Okay, so kinetic energy at the highest point, so at the highest point K dash is equal to K cos square theta. So K cos square 45. So cos 45 1 upon root 2. So that is k by 2. So k dash is equal to k by 2. K dash is equal to k by two balls of same mass are projected, one vertically upward and the other at an angle 60 with vertical. So other at an angle 60 with vertical. The ratio of their potential energy at the highest point. The ratio of potential energy, so that is already we have discussed. So that is K. So that is K sine square theta. That is K. Suppose initial kinetic energy is same. Okay, then K cancel. So in first case angle sine square theta, instead of that I can write sine square 90. In second case sine square 60. No, always angle should be with horizontal. So here I have to write sine square 30. So sine 91, sine 30 1 upon 2, 1 upon 2 square 1 by 4. So answer is 4 is to 1. The ratio of their potential energy 4 is to 1. The above problem, kinetic energy at the highest point for the second ball is K. So for the second ball, kinetic energy at the highest point, that is K. What is the kinetic energy for the first ball? So for the first ball at the highest point, so kinetic energy K dash is equal to K cos square theta. So now here theta is equal to 90. So cos 90, 0. So answer is 0. So answer is E option. So that is 0. Okay. The highest point, again kinetic energy highest point is 0. Why? At the highest point velocity becomes 0. Kinetic energy also 0. So naturally answer should be a ball is thrown at an angle theta with horizontal. Okay. So its initial kinetic energy is 100 joule. So initial kinetic energy, so that is 100 joule. It becomes 30 joule at the highest point. And angle of projection. So here if you don't know the equation, then really it will be difficult. So K dash is equal to K cos square theta. So K dash is given 30, K is 100, cos square theta. So we want to find theta. So cos square theta is 3 by 10. So cos theta is equal to root 3 by 10. So theta is equal to cos inverse under root 3 by 10. Theta is equal to under root cos inverse under root 3 by 10. So we will stop here. So in the next lecture, we will start horizontal project. Okay. Thank you.